Last time we started the differentiation and integration of power series. Let's suppose that the power series n equals 0 to infinity, Cn x minus a to the n converges. And then what I told you last time was when we differentiate that power series, we can do term by term differentiation. So if we do, then that becomes n times Cn times x minus a to the n minus 1 power. So that's just the regular differentiation. When n equals 0, it vanishes, so we start from n equals 1. The same thing is true when we think about the integration. When the series converges, integration of that power series will be the term by term integration. So integration of summation Cn x minus a to the n power can be written as n equals 0 to infinity integration Cn times x minus a to the n power dx. So that can be written as n equals 0 to infinity Cn times x minus a to the n plus 1 power over n plus 1 power plus c. Now we do some examples to learn about how to apply those principles. Find the power series representation and the radius of convergence. The way we figure out the power series representation in this case will be relating this one as the derivative of 1 over 1 minus x. So we think about f of x equals 1 over 1 minus x, which we know what the power series expansion is that comes from geometric series. Then when we think about f prime of x, we differentiate 1 over 1 minus x. Of course, that can be written as 1 minus x to the negative 1 power. And then we bring down, so negative 1 times 1 minus x to the negative 2 power times chain rule. So we differentiate this part, and then that is negative 1. So negative will make positive, and so that end up being 1 over 1 minus x squared. So this function is the derivative 1 over 1 minus x, and when that converges, we can do term by term differentiation. So we can rewrite that as n equals 0 to infinity d dx x to the n power. Then that is summation n equals 0 to infinity n times x to the n minus 1. But when n equals 0, things will become 0. So we can start it from n equals 1 to infinity n times x minus x to the n minus 1 power. We know that this is a geometric series. The radius of convergence is 1 that converges when absolute value of x is less than 1. So radius of convergence is 1 because the integration and the differentiations of the original power series has the same radius of convergence and interval of convergence. The second case is natural log of 1 plus x. What we know is an integration of natural log of 1 plus x dx is and that integration of 1 over 1 plus x dx is natural log of 1 plus x, of course, plus c. Right, and so power series of natural log of 1 plus x can be obtained by integrating the power series of 1 plus 1 over 1 plus x. So we want to expand this as a power series. To do that, what we remember is 1 over 1 minus x is summation n equals 1 to infinity n times x to the n. No, this is 1 minus x is summation n equals 1 to infinity the 1 plus x n 1 plus x to the n power, right? But it should start x equals n equals 0. And then we have to write that down as 1 over 1 minus x dx. Because we want to relate that with this formula. So what will happen will be, instead of x, we write negative x. And so integration n equals 0 to infinity, negative x to the n power dx. So what is this? Integration 1 minus x plus x squared minus x cubed dx. So n equals 0, then 0 power, anything to the 0 power equals 1. When n equals 1, that becomes negative x to the 1 power, which is x if n equals 2. Then that is negative x squared, which is x squared, and so on. We will just integrate. So term by term, then that is negative x minus x squared over 2 plus x cubed over 3 minus x to the 4th power over 4 plus and so on plus c. If we summarize this, then it becomes natural, the summation n equals 0 to infinity, negative 1 to the n power times x to the n plus 1 over n plus 1 plus c. Why is that? Because when n equals to 0, this is positive, and so negative 1 to the n power should be positive. If that is 0 power, anything to the 0 power is 1. So this is the right expression, because that is alternating and start with the positive number. When n equals 0, the first term should start with x. And so this one is x over 1. So it should be n plus 1. When n equals 0, then this part will be negative 1 to the 0 power, x to the 0 plus 1, 1 power over 1. So it'll make this. And so as long as that this one fits into this expansion, that is the correct expansion. And then there is some imperfection here, because this part is the power series, but c is added, right? So we have to figure out c. So if x equals to 0, then natural log of 1 plus 0, we go back to here to evaluate c, equals natural log of 1, and that equals 0, right? And so what does that mean? If you put x equals to 0 here, then we have summation n equals to 0 to infinity, negative 1 to the n power times 0 to the n plus 1 over n plus 1 power. And so this part is always 0, and summation part equals 0 plus c, and those must be the same. So c equals 0. And then natural log of 1 plus x. So we are relating that with this part, c equals 0, and so those must be the same. So natural log of 1 plus x is summation n equals 0 to infinity, negative 1 to the n power, x to the n plus 1 over n plus 1. And the radius of convergence equals 1 because we know that this one is a geometric series and that converges when x is less than 1 and radius of convergence is 1. Any question? The next problem is 1 over 6 plus x squared. So we want to consider this one as a derivative of 1 over 6 plus x. And then we want to relate that, relate the power series, differentiation of the power series of 1 over 6 plus x with this one. So let's consider the power series of 1 over 6 plus x. Then that becomes, we take out 6 from the denominator. Then we have 1 over 6 times 1 plus x over 6. And so when we multiply this, this is 6, and this times this one will be x, right? So x over 6. And so that is 1 over 6 times 1 over 1 minus x over 6. So we always keep in mind the geometric series expansion, and that is 1 over 1 minus x summation n equals 0 to infinity x to the n power. So that is 1 over 6 times summation n equals 0 to infinity minus x over 6 to the n power. Then I said we want to relate the derivative of this one with this function. So let's consider the derivative of this one. Derivative of this one is of course ddx 6 plus x to the negative 1, which is dx negative 1 times 6 plus x to the negative 2 power. So that becomes negative 1 over 6 plus x squared. So those are related to each other, but this is negative of the given one. So when we write 1 over 6 plus x squared, that is ddx. We multiply -1 here and -1 here. So ddx -1 over 6 plus x squared. So that -1 minus 6 plus x, we multiply by minus on both sides, and so that's squared. And so this one becomes -1 times d dx 1 over 6 plus x. And then we differentiated the 1 over 6 plus x. So that becomes -1 times 1 over 6 dx summation n equals 0 to infinity negative x over 6 to the n power So that means that is negative 1 over 6 times n equals 1 to infinity, n times negative 1 to the n power. And then we can write it down as x over 6 to the n minus 1 power, 1 over 6. So we apply the chain rule here. And then we combine all of those. Then we get n equals 1 to infinity, negative 1 to the n plus 1 power because of these two, times n times x to the n minus 1 over 6 to the n plus 1. So what's happening here is n comes from here, and you distribute the power. So x to the n minus 1 power, and 6 to the n minus 1 power, and then times 6 will make 6 to the n times 6 one more time will make 6 to the n plus 1 power. So in the exam, I think this will be enough, but depending on how WebAssign is asking you the question, I mean the format related thing, if that start from n equals 0, and then you have to adjust it a little bit. If n start with a 0 instead of n starting from 1, then we just raise the power one more time. So instead of n plus 1, you have to start with n plus 2, right? Because when n equals 1, n plus 1 will make 2. And if n equals 0, then we have to add 2 instead of 1, right? To make 2. And then, so by doing that, we get n plus 1 times x to the 1 more, then we get x to the n power over 6 to the n plus 2 power. So we can write it down as n equals 0 to infinity, negative 1 to the n power y set because this one will be -1 to the n power times -1 squared. And so this one equals 1, right? And then n plus 1 times x to the n power over 6 to the n plus 2 power. So radius of convergence is 6. That is because absolute value of negative x over 6 is less than 1. So absolute value of x is less than 6. So we go back to here. So we think about the ratio, which was negative x over 6. The next problem is related to the previous problem, 1 over 6 plus x cubed. So that is ddx 1 over 6 plus x squared. Then that is ddx 6 plus x to the negative 2 power. So if you differentiate that, then you will get -2 times 6 plus x to the negative 3 power. So that is -2 over 6 plus x cubed. So what we can do about the given one is 1 over 6 plus x cubed equals -1 over 2 times d dx 1 over 6 plus x squared. What we are doing here is the two are the same. And we are to get 1 over 6 plus x cubed, we have to divide by -1 over 2 on both sides. So we multiplied by -1 over 2 to the derivative of 1 over 6 plus x squared. So x squared. And then we go back to the previous result right here. Look. Yeah, previous result. And then that becomes -1 over 2 ddx summation n equals 0 to infinity, -1 to the n power times n plus 1 x to the n power over 6 to the n plus 2 power. So this is the power series expansion which we obtained, but this time we are differentiating one more time. So then that becomes -1 over 2 summation n equals 1 to infinity, -1 to the n power times n plus 1 times we differentiate this part, then we get n times x to the n minus 1 power over 6 to the n plus 2 power. And then this part can be written as -1 times 1 over 2. And this one can be combined with this one. Then what we can say is that becomes n equals 1 to infinity, -1 to the n plus 1 times, we are putting this one here, and then 1 over 2 times n plus 1 times x to the n minus 1 over 6 to the n plus 2 power. So that equals n equals 1 to infinity, -1. We want to start it from 0. So we raise the power by 1. So n plus 1 becomes n plus 2. 1 over 2 times, instead of n, we write n plus 1, and then n plus 2. X to the n minus 1 plus 1 will make n, and 6 to the n plus 3 power. So this one is -1 to the n power times -1 squared. This one is 1. So that is summation n equals 0 to infinity, -1 to the n power times 1 over 2 times n plus 1 times n plus 2 times x to the n power over 6 to the n plus 3. In the previous problem, we already know the radius of convergence. In this problem, radius of convergence come from absolute value of x over 6 is less than 1. So absolute value of x is less than 6 by multiplying by 6 on both sides. And so radius of convergence is 6. And the next problem is obtained by differentiating the previous one. So the radius of convergence is 6. The next one is x squared over 6 plus x cubed. So in this case, that is just a x squared over 6 plus x cubed. And so that can be written as x squared times 1 over 6 plus x cubed. So that becomes x squared times summation n equals 0 to infinity. We are going back to the previous problem, which And we already expanded it, and we just multiply by x squared. So that is -1 to the n power times 1/2 times n plus 1 times n plus 2 times x to the n power over 6 to the n plus 3 power. And then we want to put this back here. Then we get n equals 0 to infinity, -1 to the n power times n plus 1 times n plus 2 times x to the n plus 2 over this one, 2 times 6 to the n plus 3 power. So radius of convergence is 6 as before. So any question? So today what we did was a pretty mechanical process, but we always use 1/1 minus x equals summation n equals 0 to infinity x to the n power. Of course, this comes from the geometric series, right? So tomorrow I will do the problem which is related to the integration. And then I will move on to 11.10, which is about Taylor series and Maclaurin series. So if you don't have any question, then you can leave. But if you have question, then you can remain and ask me question.